All right, now we're going to move on to 3.3, which is real zeros of polynomials. Couple theorems here to start off with. First of all, the rational zeros theorem states that for this polynomial, every rational zero is in the form p over q, where p is a factor of the number at the end, and q is a factor of the number up front. So I'm going to kind of jump down here and fill out the possible zeros here on number 1. And so I'm going to make a big fraction here, and we're going to state all of the factors of the number out back and up top. So what are the factors of 10? Well, we got 2 and 5, but we also have 1 and 10. And then in addition to that, I'm going to put a plus or minus in front of all of these, because how could I multiply to make 10? Well, I could use 1 times 10, but I could also use negative 1 times negative 10. So anytime you do this, you're going to do a plus or minus in front of all your numbers, okay? And then on bottom, we're going to put the factors of all the numbers in front. So in that case, this is just 1. So that means if I divide these out, I get a list of all the possible numbers. So if I do 1 divided by 1, that's just plus or minus 1. 2 divided by 1 is just plus or minus 2. 5 divided by 1, of course, plus or minus 5. And then 10 divided by 1 is plus or minus 10. So what this is telling me is that when I do my synthetic division, this gives me the list of numbers. There are 8 numbers on this problem in total that I would have to try out. 1, negative 1, 2, negative 2, 5, negative 5, and 10 or negative 10. So we're going to get to that synthetic division in a minute, but like I said, instead of checking every number in the universe, that limits that list down to 8. All right, next up we have some time savers here. I'm not going to dwell on these a ton. But if you do see them, you can use them. So if you synthetically divide by a positive number c, and the result, and every number on the bottom row is positive, then c is the highest possible zero for the function. So there's not going to be any that are higher than that. If you synthetically divide by a negative number, and the results are alternatively non-positive and non-negative, then c is the lowest possible zero. So all of them are going to be bigger than that. All right, so now what I'm going to do, I'm going to find all the zeros, and so I can pick any number from my list here. Like I said, we have 8 numbers to try from. I'm going to go ahead. I always like to start with 1. I just think that that's the easiest number always to do, so I'll go ahead and do that. Okay, so I get 1, 1, negative 5, negative 5, negative 2, negative 2, and 8. So we are looking for a 0 at the end there. So we're trying to find all the zeros. So I'm going to cross that off. And I'll go ahead and try a different number. So I'll go ahead and try negative 1 now. I think that's the second easiest number to use. So I go ahead and I always do that second. So this is going to be 10, negative 10. And that does give me my 0. So since I was at the third power here, I can rewrite this now as x plus 1 times x squared minus 7x plus 10. And then I'm going to go ahead and factor the leftovers here. And so that would be negative 5 and negative 2. No a value there, so I can go ahead and just write this as x plus 1, x minus 5, x minus 2 in the factored form, which mean I have zeros at negative 1, 5, and 2. All right, next up here we have number 2. So let me make my possible zeros list here. So I'm going to make a big fraction. The number out back is 9, so I need to do 1, 3, and 9 are the factors of 9. I can do 3 times 3 or 1 times 9. And then 2 is out front, so I have plus or minus 1 and plus or minus 2. So for this one, I need to divide kind of all of these to get my list. So I have 1 over 1 is, of course, 1. 3 over 1 is 3. 9 over 1, of course, 9. But then I also have here 1 over 2, which is 1/2. 3 over 2. And 9 over 2. So I do have some fractions in there as well. This list now I have, let's see, 12 numbers in there with a plus or minus, six pairs of pluses or minuses. I'm just going to go ahead and start off with 1 again here and see what happens. So I'm going to go, I got 2, 2, 9, 9, 8, 8. Negative 7, and that one's not going to work. So I'll switch over to negative 1. That's usually the place I go next. Try that out. So 2, negative 2, 5, negative 5, negative 6, positive 6, negative 9, positive 9, and that one did work out. Now in this case, Started at the fourth power, so I'm going to need to find 2 of these. So I just got 1, and now I'm going to try to find my second one using these leftovers right here. Why don't I go ahead, let's see, let's go ahead and try 3 then. And once again, I'm going to do 3 on those leftovers. So we got 2, 6, 11, 33, and this one is going to be 27. I can already tell this is going to be too big, so I'm just going to go ahead and stop there. Let's go ahead and try -3 and see if that works. It's going to give me 2, -6, -1, +3, -3, +9, and that one does work. So I have x plus 1 for the -1 that worked, x plus 3 for the -3 that worked, and then I have left over 2x squared minus x minus 3. So I'm going to go ahead and factor that. And so I'm going to think 2 numbers multiply to -6 and add to -1. So I think that'll be -3 and +2. Now in this case, I do need to do my grouping technique because I have that 2x squared out front. So the first group, so I'm going to group these up. First group, I can take out an x. Second group, I can take out a +1. So it's going to give me x plus 1 times 2x minus 3 to go along with my x plus 1 and my x plus 3. And so I have here my zeros, -1, and I'm just going to go ahead and say multiplicity 2 here, since you can see that's now showing up twice. And then we have x equals -3, and then x equals 3 over 2. You'll notice that that 3 over 2 that I found over here by factoring, and the -1 I found by factoring, were in fact in my original list of rational zeros. All right, next up here we got number 3. So we'll make my list of possible zeros again. So we got 4 in the back, so it's ±1, ±2, ±4. I have a 1 up front, so it's ±1. So whenever you have just the 1 on bottom, it's really just the list of the numbers up top. So 1, 2, 4. So I'm going to go ahead and start with 1 again. All right, so we get -1, -4, 4, and that one actually works out. So I actually noticed here, so that one worked out, and we were at the 4th power. So normally we would kind of keep checking those numbers, which would work. But I actually noticed here that the ratio is the same as 1 to -1 on both of these kind of leftovers here. And so that tells me that factoring by grouping may work here. I know it will actually, but it's something you should at least check out. So if I write down these leftovers, if I write this as x minus 1 for the one that worked, and then I have x to the 3rd minus x squared minus 4x plus 4 as my leftovers there. I notice here that I'm going to check out this grouping. So if I take out an x squared here, I get x minus 1, and if I take out a -4 here, I also get x minus 1. So if you can get these two parentheses to match when you have 4 terms like this, that means the grouping does work. I'll tell you, it's not going to work every time. It did not work on the previous one, but on this one it does. And so we get here at x minus 1 squared, kind of taking the one out front and the one out back, and then I'm going to refactor this to x plus 2 and x minus 2. So watch out for that grouping when you get down to 4. If you get down to 4 terms, like I said, it's not going to be there every time, but sometimes it will. So now I'm going to graph this where I have my zeros at 1, which is a multiplicity 2, which we know is going to be a bounce. We have 2 and we have -2. So I have a degree 4 positive here, so we're up and up. We got 1, we got 2, we got -2, and then the 1 is going to bounce. So there we go, and there you go. All right, and last up here, number 4. So our possible zeros here are 1 and 2, ±1, ±2. Since we have the ±1 on bottom, it's just those top numbers. So I'll go ahead and try out 1, like you guys know I like to do. Just an easy number to do. So get 1, 3, 1, and that one actually did work out. Now in this case, I am down to 4 numbers here, but you can see this 1 to 3 ratio is different than the 1 to negative 2 ratio, so the grouping will not work on this one. So I'm going to try out just another number on those leftovers. So I'll go ahead and try out -1 in this case. So I get 1, -1, 2, -2, -1, and 1, and that gives me -1. So that one does not work out. So I'll go ahead and try out 2. Once again, I'm doing this on the leftovers. Actually, I don't think 2 is going to work because there's too many positive numbers at the beginning, so I'm going to switch to -2. Yeah, and what I was thinking there is if we use 2, I could just see all these numbers getting big positive here, so it's not going to get down to 0. So I'm just kind of anticipating that. You can do that if you can see it. If not, we could have just tried it out. And so this one does work. Okay, so we get x minus 1 for the positive one that worked, x plus 2 for the -2 that worked, and we're left with x squared plus x minus 1. Now, we can try to factor the leftovers there at multiplying to -1 and adding to 1, but there are no 2 such numbers that do that. So I'm going to have to switch to the quadratic formula here. -1 plus or minus the square root of 1 minus 4 times 1 times -1 all over 2 times 1. So that would be -1 plus or minus the square root of 1 plus 4 is going to give me 5 all over 2. So if we're gonna, these are 2 real zeros, and if we're gonna graph them, I would say we should use a calculator to figure out what they are. Okay, so if I'm typing this in my calculator, I would type it in once as, you got to do parentheses here, -1 plus rad 5 divided by 2. So let me do that. Got to make sure you do that extra set of parentheses there. So that gives me 0.61. And if I did that again, but now with a minus, so this is how we do plus or minus on the calculator. Some people sometimes ask me, where's the plus or minus button? There isn't one. It just means you do it once as a plus and once as a minus, and so this one will give me -1.61. So I also have my, so those are my 2 decimal x values, so I'll just kind of estimate where they are, probably about there and there. I also have a -2, let me zoom in here, a -2 and then a +1. We're degree 4 positive, so it's going to be looking like a W again. And, oops. Oh no, I drew that 1 in the wrong spot. Shoot. That should go right here. So they're really jam-packed in here. So yeah, there we go, there we go, there we go, and there we go. Okay, so it looks good.